Okay, now the quality work I saw on the quiz is much better than last time, so I was making good progress. You're not quite there yet, but it's a good halfway to get the other halfway by Tuesday, okay? And writing things out, and I'll make some comments as I go through the problem, things that I wanted to see and didn't always see, although I think if I take the class as a whole and put your heads together, you get every bit of it, okay? So, and several people did quite well, everybody knew some stuff, so good start. One piece of advice, if you in my MDE 61 classes, several of you are, so you've heard it already, but so I'm just going to repeat it kind of quickly. I really recommend that after you've worked with problems, a lot of problems you're going to work, watching the videos, getting some help from the videos and so forth. Put those away, come back the next day, or come back to full class and see if you can work all the problems without looking at anything. Okay? That's the test of whether you've learned it or not. Okay? Learning how to do a problem by just watching a video and imitating the video, it doesn't necessarily stick in your brain because you're busy imitating the video. You're not thinking through the problem. Now, some of you obviously are. Some of the quizzes were pretty good and everybody's making good progress. Okay? So, but try to nail it as best you can because this course gets harder. Okay? Okay. Well, graph of the reciprocal square function. Yeah. Let's see a table. I didn't usually see everything I wanted to see. We want to see the calculation. Of course, this is y plus 1 over x squared. Not everybody did the right function. Some people did the exponential function. So that's okay. It was well done. Okay. You can do that one, you can do this one, but you got to know the names. You matched up the names on the homework. Okay. And this is what I mean by do these things without looking at a list or a picture or something. Okay. Go back and see if you can match up the names with the function and with the formulas, right? Okay. Anyhow, this is 1/4. And there's your calculation. There's calculation for -1/2. You got to know the rule for division because this means 1 divided by 1/4, which means 1 times 4 over 1, 1 times the reciprocal. That's a rule of arithmetic. And if you don't know it, make yourself a note and make sure you do. Okay? You've known it at one point or another. What are zeros undefined? And this one comes out the same as the -1/2 squared. There's your table. I probably ought to have that on the video. No, it's recording. Camera. Okay, this is risky. Did we lose focus? No, we still are. Okay. Here's a camera. Oh, man, it goes too far. Anyhow. I hate to zoom back because every time I zoom, I risk losing focus. Okay, there we go. Okay, so there it is, table. And the graph is moving up. I'm not going to label everything. So our points are going to be 1/2, -1/2, 4, 1, 1, and -1, 1, and -2, 1, 4. And similarly here, here, and here. Now a couple of comments. That's the function. That's the basic function. That's all. There's no more for the basic function. Okay? And it's domain and range. I didn't ask you for the domain and range, but presumably it told me. You know, domains you set of all x values, which is -2, -1, -1/2, 1/2, 1 and 2. You exclude 0. Okay? You don't try to connect these points because you would be assigning a value for x equals 0 if you were to cross the y-axis, right? So that doesn't work. Same as for the 1/x. So your domain is this set of numbers, and your range is just the numbers 1/4, 1/4. Okay. So make sure you understand that. I'm not going to write it down because he's doing this. So here's your basic function. Now, I didn't ask for it, but the extended basic function, just to remind you, and I probably will ask for it sometime early in the future. I'll just do it in dotted lines, so I don't. A basic function is 6 points. Extended basic function I'll write it like this. It's a curve that starts here and ends here, then picks up again here and ends here. Okay. And I've shown you already how to write that in interval notation. I'm not going to take time today to go over it. Okay, well, that's it. Then, as I say, people did pretty well on that. But if you didn't show me the calculations, I don't believe it. I think you used a calculator or you used something inappropriate and you didn't go through the steps of the calculation. I don't really think that because most people would skip the calculation. I'm pretty sure know how to do it. But if you don't show me that you know how to do it, I get credit for doing it. Okay? Because I got to see it from everybody. I don't want to make guesses about whether you know it or not. I want to see every bit of it. Okay? And the reason for that is you really need to understand these functions. And you don't understand them unless you understand the calculations. Okay. So again, that looks pretty good overall. So I'm pretty well pleased with what I saw. Okay. Okay, what this one? This is 5x plus 9. Main is restricted by the fact that the thing you take the square root of can't be negative, so it's got to be greater than or equal to 0. So you automatically, when you have an expression under radical, set that greater than or equal to 0 and solve for this. Okay? Now, the expression under here might be really ugly and you might not be able to solve it for x. In this case, it's not a problem. 5x plus 9 greater than or equal to 0. And we'll see the stuff. 5x plus 9 minus 9 greater than or equal to 0 minus 9. So 5x is greater than or equal to negative 9. So 5x over 5 is greater than or equal to negative 9 over 5. So that x is greater than or equal to negative 9 over 5. And that means that the domain is the interval negative 9 over 5 infinity. Okay. Now I'm pretty sure everybody's algebra is up to this. Simple linear inequality. If not, you better review it. Okay. Make sense? Okay. Now you got this f of x thing. Okay, let's say for your numbers f of x was x squared plus 20x minus 3. Then we wanted to find f of your a number. Now, your e number would not have been 3, but yeah. So if your a number is 5, x has been replaced by 5, so replace all your x's by 5, right? And that gives you, that's 100, that's 97, 25, 122, I think. Okay. F of six plus 7, of course, is f of 13. Now, I'm going to put 3 dots here. I'm not going to write out all the arithmetic, but I know 13 squared is 169, that's 260. And 169, 260 is 400, and I'm losing my numbers. 169, yeah, 429. So this is 126. Put a question mark there. Who knows if my brain functioned right that time, but I kind of think it might be right. Okay. Now the point I want to make here with this problem is the next question would be f of 6 plus f of 7. Okay. Well, f of 6 plus f of 7 is not the same as f of 6 plus 7. With some functions, if it's a linear function, actually it would be. Otherwise, it won't be. Or it'd be very unlikely it would be. Okay, so f of 6, well, that's square 6, you get 36. That's 120, so that's 156. So you have 153. And then you have 7 squared is 49, 140 is 189, and then subtract 3, you get 186. That's 339, I think. Okay. Now, these aren't the same. So I'm going to draw your attention to the fact that why would I write a 9 when I was trying to write an F? Okay, it's not equal, right? There's a common misconception with functions that you have this kind of distributive law that f of 6 plus 7 ought to equal f of 6 plus f of 7, right? But there's no reason to expect that. Okay, that's only true if it's have a linear function like the y equals mf plus b function. Okay, then you have f of u plus v. And my white chalk eventually. Here's where most people didn't get this. I don't know if anybody did. I didn't see any that didn't look carefully at all the questions. First place, you got to understand that u and v are variables. They're just letters. They're symbols for variables, symbols for numbers. Okay. But there are no backward apostrophes here, nothing to indicate that those would be actual fixed numbers. Okay. So f of u plus v, you plug in u plus v for x, right? And x is going to be u plus v. So x squared is going to be u plus v quantity squared. 20f is 20 times u plus v. And then minus 3 is just minus 3. That v looks like a v. Okay. Now, then you really want to kind of make yourself a note to pay attention to what I'm doing here. What's this one? Crumbs, you deserve more privacy. Crumb yourself off my screen. Okay. Okay, so u plus v quantity squared is u plus v times u plus v, right? Now 20 times the quantity u plus v is 20 times u plus 20 times v. And of course, you got your minus 3. Everybody with me so far? Something's a little off. Okay. I think we can see enough of the top, but I'm not going to mess with it. What I am going to do, in case anybody's watching this, and they can see what I'm thinking is, it wasn't quite visible. Okay. Anyhow, u plus v times u plus v. How are you going to do that? We're going to use the distributive law. U plus v times u plus v is u plus v times u plus u plus v times v. Distributive law. This times this plus this is this times this plus this times this. The distributive law. Then you have your 20u plus 20v minus 3. Okay. Now, what's u plus v times u? Well, that's u times u plus v times u, right? U plus v multiplied by u means u times u plus v times u. That's your distributive law again. Same thing over here. And have a u times v and a v times v. Then you have it plus 20u plus 20v minus 3. Well, u times u is u squared. V times u is the same as u times v, isn't it? Yeah, commuter's law. It doesn't matter what order you multiply two things. So that's a u times v. You could write that as u times v. And here's another u times v, giving us 2u times v, right? So you have 2 u times v plus v squared plus 20u plus 20v minus 2. This is important because this is going to prove that in general, you don't have a distributive law for function notation. So f of u plus f of v equals what? F of u is u squared plus 20u minus 3. And f of v is v squared plus 20v minus 3. Gives you this. Okay. So we got a u squared, we got a v squared, let's put those here. Because we usually put the higher power terms first. And a 20u and a 20v, well, they match up kind of nicely. That's what we have over there. And then we have minus 6, not minus 3. So what matches and what doesn't between this and this? Well, what matches is the u squared and the v squared, and the 20u and the 20v. I've got to take back something I said before. I said you have a linear function, then f of, if it was a linear function, f of 6 plus 7 would equal f of 6 plus f of 7. It's not true. Okay. If f of x is a multiple of x, then you would have a distributive law. If you've got a constant term in there, like a minus 3 here, you see what happens. You get a minus 3 for the f of u, and you get a minus 3 for the f of v, so you get minus 6 there, and that doesn't match, right? Okay. So you want to kind of put an x here, this doesn't match this, and this isn't even there, right? So those are places where these two expressions are different. So please don't let me see people thinking that f of this plus that equals f of this plus f of that. Almost never true. Okay. Okay, well, that takes care of the quiz, which took care of 2/3 of our class period, but that's all right. The important things. And what we have to do next, I don't think it's all that bad. Let's say your pound is worth $25,000 today. You got to account for 25,000 a day, 37,000 6 months from today. How quickly we just say the value is changing? Okay. I don't write out the whole question, but just write out your answer to how quickly you might say the value of the account is changing. And I'll take a look at what you're writing, just see what you're thinking. As soon as I try to get the camera back in focus. Just doesn't want to focus. Okay, there it is. Don't write out my question, write out your answer. That's later at that time. After the video. I want to see your thinking. I asked, how quickly did that account change? What would you say? Yeah, you're on the right track. You didn't get an original answer, but give me a statement that it's changing. Good. Okay. Don't want to take any more time on this. I can't read a lot of your writing. But I assume it's pretty good. Because the ones I could read were. Okay. I would say there are two possible answers. I would say $2,000 per month. Okay. Of course, that doesn't mean it changed by $2,000 every month, does it? Okay. It means on the average, it was $2,000 per month. Some months it might have been more, some months it might have been less, but if you change from 25,000 to 37,000, well, it's pretty simple to see that that's a $12,000 change in 6 months. And you divide $12,000 by 6 months, you get $2,000 per month, right? That's $2,000 per month on the average. Make sure I'm still in focus. Yep. Okay. That's one answer. This is a good answer, right? Or I could say, $24,000 a year on the average. I'm trying to project how much I might gain in a year based on what I gained in 6 months. That might be my projection. I wouldn't take account of the tendency to think that I have an exponential nature, but that comes later in the course. Okay. So right now that would be a reasonable projection. Even if you're taking advantage of the exponential nature, it's still not an unreasonable likelihood. Okay. Now we could say 6 months is 180 days, right? If we divide 12,000 by 180, then we get $667 a day. What's wrong with my calculation? Okay, I'm sorry. I don't know what went wrong. I got 667. That's ridiculous. Okay, I think $66.67 per day. We just divide the $12,000 difference by 180 days. Okay. 180 times 100 is 18,000, and this is 2/3 of 18,000. And again, that's on the average. Lots of ways I could answer the question. I didn't specify what units I wanted in, but the natural unit would be per month, since I'm talking about month, right? Okay. So the average rate is the change in value divided by the change in time. Okay. Okay, well, I can take this information and put it on a graph. So I don't know what the scale of this graph is. I don't know where the origin is, but we have now and we have now plus 6 months, right? And we have 40,000. All right, 40K, that means 40,000. K standing for kilo, which is 1,000. Okay, so now I have $25,000. Well, 25,000 is halfway between 20,000 and 30,000. Now is here, so I can get the point here. Okay. And that's now 25,000. And then 6 months, I have 37,000, right? So 37,000 be about here. Oh, no, plus 6 months is just what I said it was. So here it is. Oh, dollar sign. So I have this point and this point. Well, what's the slope of the line segment between these 2 points? Okay, well, let's have a little conversation. Tell me what you think you know about slopes or what you know about slopes. Okay. So, took a while. I got a lot of good words, words like ratio, rate, okay? Just a bunch of good words. Ratio has more to do with this than any of the others, and they're all good mathematically related words. So I appreciate all those answers. But took quite a while to see the slope is rise divided by run. Now this is really important for calculus and for pre-calculus, obviously. Okay. I mean, even if you don't go to calculus, it's an important idea in understanding graphs and what they say. And rise over run is a whole lot better than y2 minus y1 over x2 minus x1, which is something you can plug numbers into without even understanding what it means. That's what most people know. I have about half of you remembered hearing rise over run. Almost all of you remembered y2 minus y1 over x2 minus x1. A mindless formula that was never brought into your mind, okay? And not your fault, that's our curriculum. That idea, but we're gonna fix that, okay? So slope is rise divided by run. Okay, so let's see if anybody can tell me anything about the rise and the run of this graph. Okay, so I think we got a pretty good answer. Turns out it's $12,000. Why $12,000? because you start at 25,000, you go up to 37,000. And we understand what the importance of the 12,000 is. That's how much money you gain in the 6 months, which you then divided by 6 months to get the $2,000 per month. Okay. And on the graph, where's 25,000? Well, it's over here on the y-axis. Here it is, right? So let's just label that. 25,000 is here. 37,000 is here. And from here to here is your gain. Let's call that the gain. Or change. In value, change with G in it. Not how smart, but there's your change in value. This arrow represents your change in value, which is a rise. Okay. More specifically, I can't even blame that on peripheral vision. I broke my chart. Okay, well, back to where I think I was. Okay. If I draw a triangle, the horizontal line here and a vertical line here, then I can see that the rise from this point to this point can be represented over here on the y-axis. We just go straight over to the y-axis, but we can also go over here and put it in this triangle. So here's your rise. And your rise is $12,000. Now, what do you think the run is? Let me pause the video. Okay, so knowing that the rise is $12,000, I can say that, well, that's what it is then. $12,000, we have to divide that by the run. What's the run? Well, here's the run. Okay. And the run goes from now to now plus 6 months. So that the run equals now plus 6 months minus now. In other words, this value minus this value, right? Which equals 6 months. So $12,000 I don't have room to write more. Anyhow, that's dollars over months, right? Because you're dividing dollars by month. You write that as dollars per month. You want to understand this example very, very thoroughly so that you understand the concept of slope. And it's an easy example to understand. Now, I can take this triangle and write it anywhere. Now I can write the triangle here. Okay. Pays your rise your $12,000, your rent is 6 months. This is called a fundamental triangle. Now that's just my term. I want to emphasize the importance of this triangle because there are aspects of the graph, like the rate of change, that are related to slopes, and the slopes can always be calculated from triangles of this nature. Okay? So we call this a fundamental triangle. And I guess I wrote out a definition of that. More space right here. What? A fundamental triangle for 2 points, the hypotenuse. We know what the hypotenuse of the triangle is. Show me the hypotenuse we can. And what's the direction of the hypotenuse? What's the definition of a hypotenuse? Oh, you can't say because we got the camera on. What's the longest side of a right triangle? Or the angle that's opposite the right angle. Okay. So first place, this is a right angle. And the hypotenuse is opposite that right angle. Okay. Hypotenuse connects the 2 points. So right here is your hypotenuse connecting the points. What do you call the other 2 sides of the triangle? You call them legs. Okay. One of the legs is horizontal, the other leg is vertical. That is parallel to the x-axis, parallel to the y-axis, right? Horizontal leg, which is parallel to the x-axis.
Okay.
It's a right. Sort of, there's a little qualification on that. We'll get to that in a minute. The vertical leg. Is the right. You got to be a little bit careful because you have to have a direction. So when you do a fundamental triangle, you say, okay, basically usually going to go left to right. So if I travel from this point to this point along the hypotenuse, then I'm traveling in this direction, right? Now, if I want to get from this point to this point along the legs, let's see, does this get me from this point to this point? No, it gets me over here, but then I have to be going down. Okay. This one gets me. Right? So the run is from here to here, the rise is from here to here. Meaning if this point was lower than this point, your rise would be, well, you'd go like this and then like this, right? meaning your rise would be negative. Okay, well, slope is short of your vertical leg divided by your horizontal leg. And that represents the average rate of change. There's a connection between your average rate of change and your graph. There's a little more to these triangles than I've said, but kind of keep that in mind. It's a change in one quantity divided by the change in the other. Formula is y2 minus y1 over x2 minus x1 if you put it on a graph. But it all has meaning, and we want to use the terminology rise and run to really understand what we're saying.